Hello guys, welcome back to my channel, Mason African Motives. Still working on engineering science N3. In this part we shall be working on the question paper which is on forces. Okay, so that's the question that you're going to be referring on. So guys, not to miss these classes, make sure that you subscribe to my channel, Mason African Motives, working on engineering science N3, mathematics N3 and all other subjects, so you can actually work from that. Okay, anyways, the first question that you're given is to define the term triangle of forces. Okay, we understand that when you are given triangle forces, you are referring to the forces that you can actually have in the form of a triangle. So how is this going to be in form of a triangle? These are actually three forces that you'll be having. So it's a term which is referred when three forces acting on a point are in equilibrium. They can be represented in the magnitude and direction by the sides of a triangle. So this is actually, as you can see, these forces are actually on a triangle. So the presentation of these forces is supposed to be three, because a triangle is also three equal sides. There's three sides, I mean. So if a triangle has three sides, then we must have three forces. So that is the keywords that you are supposed to use here. It's supposed to be three forces because you are working with a triangle there. Okay, so simple like that. That's 2 marks for that definition. Anyways, the forces shown in fig 2 are in equilibrium and in the same plane. So if they are in equilibrium, there is something that is supposed to work there. Calculate the sum of the horizontal components and the magnitude in magnitude and direction. So we need the sum of the horizontal components that are going to be there, and these are not just the sum, but they should be in magnitude and also in direction. Okay guys, take note that when you are working with forces, actually the horizontal component, it uses cos theta. Okay, when you are working with the horizontal component, that is x there, it works with cos theta. But this is supposed to be actually the angle that you're going to take from the presentation here. How are we going to have the angle? Because our angles should be in between, or should be taken from the axis like this. Should be from either from the positive in this direction, or it's either from the negative in the other direction. That is how you're supposed to take your angles. Okay, so here we are supposed to obtain an angle that is going to affect 100 newtons and an angle that is going to affect 80 newtons. So which angles are you going to take? Let's just have a line, because this is 90 degrees, which means we are working with a horizontal line and a vertical line here. So I can actually have a continuation of this here, something like this. Let's just have a continuation of this line, something like that. Okay, so if I have a continuation of this line, guys, it means that I was having a 90 here. Okay, but now I'm having a straight line like this, and this is 130 degrees. So I can actually find this angle here. Remember, it's supposed to be from the horizontal axis. This is a horizontal axis, this one. So I'm now having this angle. How can I determine this angle? These are actually angles on a straight line. Take note. So angles on a straight line, they add up to 180. So to find this angle, we're going to subtract that 130 from 180. Okay, so 180 minus 130 is actually 50 there. Okay, so this is going to be 50. So that means this angle is going to be 50 degrees here. Okay, but take note, guys, before or previously this was actually 90 degrees, which is actually a 90 degrees. It's a right angle just like this one. So a right angle like this, it means it's 90 degrees. So here there's a right angle, and we have obtained that from this point up to this point there's 50 degrees. So you can determine from the same point but in this direction now, because this is where we are having our force. So this is going to be 40 degrees because it's supposed to be 90. So it's 90 minus 50, which is 40 degrees. So that is the angle that you're going to have there. So as you can see, each and every force is now having an angle that is acting, that is a part of that force. Okay, so we can now have our horizontal components. So let's see what, like I said, the horizontal components are the ones that which carries cos. Okay, so we have horizontal components, the ones which carries a cos. It can be hx there, so it's a cos always. So we have 100 and there's an angle here of 50 degrees, but if you have to check the horizontal component that corresponds with this 100 is on this side of the quadrant, which is on the positive side. This is actually the positive side, this is the negative side. Okay, so this one is going to be a positive because of this side where it is. So it's 100 cos 50 degrees is positive. Okay, so we have 100 cos 50 degrees, which is as positive. Okay, we move on to another one. We have this in the horizontal, so this minus 6, this 60 is actually in the horizontal, direct horizontal, and it's in the negative region, so it's going to be minus 60 as it is. There's nothing that you're going to do. If you want to use cos, you're going to use cos 180, but just leave it like that. Okay, then 70 is actually a vertical component, this one, so there's nothing that you can do on this one. Just leave it like that because it's actually a vertical component, this one. Okay, then we have 80 and an angle of 40. So this one is in this quadrant, and the horizontal here is positive, so it's going to be 40 cos 80, which is a positive because of the region that it is. Remember, say this is positive, so it's 40 cos 80 and being a positive. Cos 40 degrees, it's 80 not 40, 80 cos 40 degrees. Okay, take note, 80 cos angle 40 there. All right, so that's what we are having in this case. We can actually combine these forces together to find the horizontal component, which is our hx in this case. Okay, so we have 100. The first one, take note guys, this is 100 cos 50. Okay, 100 cos 50. Okay, minus 60, so you're going to subtract 60 plus 80 cos 40. Okay, so that's 80 cos 40. Make sure that your calculator is in degrees in this case. Okay, so that is going to be 65,562. Yeah, something like that. We just write maybe 2 3 decimal places, so it's 65,562. Okay, these were actually newtons, so it's just newtons like this. Okay, so that's the magnitude in this case, but this is supposed to be a vector quantity where we have the magnitude and also the direction. Okay, so if the horizontal component is a positive, what does it mean? This is horizontal, so this is the positive part. So the positive, as you can see, this is the east line, this is the west line, this is the north, and this is the south. So when the horizontal is positive, it's east. When it's negative, it's west. Okay, but when the vertical is positive, it's north. When it's negative, it's south. This one is horizontal and it's positive, which means it's on the east. Okay, so that is the how you take this direction. When it is a positive, it's in the east line. Negative is in the west line. Okay, that is the direction that they're talking about. So this was actually 3.21 when you are working with the horizontal component, then 3.22 now we are working with the vertical components. So we are still having the same thing, guys, on vertical components, but the only thing that we are now having is that these are now on the, like, we are referring to sine theta here. The vertical components, they work with sine theta. Horizontal components works with cos theta, something like that. So that is what you're actually supposed to have or to know from the consideration that you're talking about here. So let's take this now with sine. So we have this in the first quadrant. Remember, that's how a vertical line is supposed to be, like this. So in the first quadrant, the vertical line that is going to be there, it's a positive one here. If you're going to have a vertical line like this, it's going to be a positive. So it's 100 sine 50 as a positive, 100 sine 50 degrees. Okay, then we move on to this. Remember this one, we said it's a horizontal component, a total horizontal component, so it can never change to be vertical. So this is actually out of the vertical components. Okay, then this one is a vertical component and it's facing downwards, which means it's a negative, and it's directly vertical, so it's going to be minus 70, like that, minus 70. All right, we have this 80 here. If you are to cross check, this is going to be the vertical component, and it's in the negative region because this is positive and this is the negative region of the vertical. So it's in the negative region, so it's going to be minus 80 sine 40 degrees. Okay, so that is what you're going to have on the vertical part. So take note, guys, how you take this, the region that you are in. On this side here, the vertical components on this side, as long it's below this line, it's negative. As long it's above this line, it's positive for vertical. Okay, so you're going to combine these. Make sure that you just combine this properly using your calculator. This thing, this light is too much, that's why I'm removing this. Okay, so it's minus 70. Remember the information that we had here, minus 80 sine 40, so it's minus 80 sine 40. Make sure that your calculator is in degrees there. So you're going to obtain minus 44 comma something. Okay, and you round off properly here, so it's going to be maybe 819. Okay, so you're going to have minus 44 comma 819 newtons. Okay, so remember, you're supposed to have the direction. Remember what we said here, when we are referring to the vertical component and it's a negative, it means it is in the south. Okay, that is for the negative, so it's in the south. That is how you actually take these questions. So guys, as you can see, when you are working with forces, it's actually something that is easier, guys, too. You are simply referring to the diagram direct, that it's supposed to be the force and the angle should be taken from the horizontal components. Okay, so make sure that the angles should be found first. The angles are clear. Once the angles are clear, you can actually have this. Okay, so 3.23, we are now asked to calculate the magnitude and direction of the equilibrium force. So the magnitude and direction of the equilibrium force is actually the resultant force, which is going to make these forces in equilibrium. Okay, so how do you take the resultant force? First, you have to indicate this. As you can see, the horizontal, it's in the east, and the vertical is in the south. So which means this is actually east south. It's actually something like this in the fourth quadrant, so it's going to be in the fourth quadrant. Okay, so this is 3.23. so you are going to have the resultant in the fourth quadrant like this. This is the presentation that you're going to have in the fourth quadrant. Okay, so that's your angle. There is the direction that you're going to have, and we are given the horizontal, it's positive. This is your horizontal, 65.562 newtons, and the vertical is a negative. As you can see, this vertical is a negative, so this is actually your vertical, negative 44.819. okay, newtons. This is what we have. So this is going to be your resultant, and this is going to be the angle that you're going to have, in this case, the direction. So you have the magnitude and the direction. So the magnitude is this r, which is the resultant here. Okay, so how are we going to obtain this? We are going to use our Pythagoras theorem, which is the square root of the horizontal component squared plus the vertical component squared. Okay, so which is going to be the square root of the horizontal, and 65.5. This is, guys, we understand this from our Pythagoras theorem. Okay, so This is not supposed to be something that is amazing. Okay, this is from our Pythagoras theorem, or you can just use it direct as r squared is equal to the horizontal component plus the vertical component squared, like this. Then you're going to substitute direct, then still you're going to obtain a resultant like this at the end. So yes, just a normal application of what, of the Pythagoras theorem, nothing much. So it's 65,562, 65,562, okay, to the exponent of 2, plus this one. Even if you don't write in bracket, this one is just one and the same thing. If you don't write the negative, because you're still going to square the negative, so remember there is no effect. It's going to remain. Okay, so this is 79, that's okay, let's just see if that's 79, 417. If you round off properly, it's going to be 417. Okay, 417. This way newtons, yeah, this way direct newtons. Okay, so the resultant is just going to be in newtons like that. Okay, but we need to know the direction now. So the direction, as you can see, this is the angle that we are talking about here, which is in between here. So according to tan, you can actually use tan because this is your opposite and this is your adjacent. So we all understand that theta is equivalent to arctan. So it's going to be arctan, the opposite in this case, which is the vertical component, and this is the horizontal component. So actually there's no need for you to use this negative. The negative is just there for the presentation. Okay, so you just use these numbers as they are, which is 44,819 over the adjacent. In this case, this is the adjacent, the horizontal component, which is 65,562. all right, so what you are going to actually obtain in this case is the angle that is in between them. Okay, let's find the angle, because you're supposed to explain also about this angle. Again, it's not about actually just finding this angle. So it's your, okay, shift tan there, 44,819. okay, so you're 44,819,819 like this. Okay, over this is going to be 65,562. all right, so let's close this bracket and see what you're going to have. This is 34, something, which is 34,4. yeah, just write it as 34,4. You can even use for angles, you can prefer one decimal place, but it's not about just having this 34,4. let's see also the direction here, because if you are to cross check from this point going this direction, we are moving from the east line going to the south line, because this is the south direction that we are going, from the east going to south. Remember, we said this is east and this is south, so we are going this direction, going to the south from the east. So which means this is going to be 79,41 newtons, and the angle is going to be east. This angle 34,4 degrees going to the south. So this is what we are going to have now as the direction. So we have the magnitude and the direction. Okay, so the direction is always about where you are going from which point to which point. That is how we are going to give the resultant in terms of the magnitude. Okay, so we have the resultant, which is the magnitude, and the direction that is making it in equilibrium. So as you can see, guys, that's what we had actually to obtain these 14 marks. These are the stages that you're supposed to take or to go through in working with these typical questions on forces. So not to miss these classes, guys, that we shall be working on engineering science N3 from Memo African Motives. Just make sure that you become part of the family by subscribing, and also don't forget to share our videos to our friends and colleagues so that they also can have a benefit from this information. So till we meet again.